Hey guys, welcome back to my channel, MathSprint, and you are watching the fourth video of my calculus crash course. Today I'm going to be explaining implicit differentiation. Now, before we begin, make sure you're familiar with at least these concepts, which will be very important if you want to understand this chapter in calculus. So first understand these concepts and then continue with this video. The topics to know are basic algebra, polynomials, differentiation and its fundamental rules, and how to perform differential calculus on different types of functions. Also, for this chapter of calculus, I will only be working with real numbers and not imaginary numbers. So do keep that in mind. Implicit differentiation is a method of performing differentiation on an implicit equation with respect to the specific variable x while treating the other variables as unspecified functions of x. Now, you might be wondering, what is an implicit function? An implicit function, you could say, is essentially a relation consisting of two or more variables with an expression on the left-hand side of the equation containing the variables, constants, and coefficients, and the right-hand side being zero. So, for example, x squared plus y squared minus 1 is equal to 0. That's an implicit form. That's an implicit equation. Here, x squared plus y squared minus 1 is the implicit function. For many implicit functions, it's difficult to express one variable entirely in terms of another variable. If you encounter an implicit equation, such as the one below, x squared plus xy plus y squared is equal to 1, you may at first feel compelled to find dy by dx by using explicit differentiation, meaning you find y in terms of x and then differentiate y in terms of x. But for the problem that I've presented on this slide, you probably realize that it's going to be too difficult to find y in terms of x. So we have to put explicit differentiation off the table and focus on using implicit differentiation instead. And with implicit differentiation, we can find out that dy by dx is equal to minus 2x minus y, the whole thing divided by x plus 2y. Now, I'm going to be showing you how to do implicit differentiation by showing you some basic steps. The first step, differentiate both sides of the equation with respect to the specific variable x. So essentially, you have to apply the operator d by dx on both sides of the equation. Then, the second step, use the rules of differentiation to expand the left-hand side and the right-hand side. All other variables, unless they're constant, are functions that can be expressed in terms of x. So you'll probably have to use different rules of differentiation, such as the product rule, quotient rule, the chain rule, sum rule, and others. I've discussed all these rules in my second video of the calculus crash course. So you might want to take a look at that video if you want to brush up on any of your concepts in differential calculus. Now, let's focus on step 3. Take all the functions that are multiples of dy by dx on the left-hand side. So basically, we're taking all of the dy by dx on one side of the equation. Then express the left-hand side as a product of dy by dx and some other function. So you could say we're just taking dy by dx out and making the entire LHS, the left-hand side, as the product of dy by dx and some other function. That other function could be, say, x plus 2y or just 2y or anything, actually. Then we divide the LHS and RHS, that is the left-hand side and right-hand side, by this other function that I mentioned in step 4. And that allows us to get an equation for dy by dx. So I mentioned like how on the left-hand side, dy by dx could be, we could have dy by dx multiplied by, say, x plus 2y, another function. So essentially, we divide the left-hand side and the right-hand side by x plus 2y, and that'll give us the result for dy by dx. Now let's do a problem. If x squared plus y squared is equal to 2, find dy by dx. I'm going to link our entire solution to all of the steps that I mentioned on the previous slide. So we have to find dy by dx. The first step, differentiate both sides of the equation in terms of x. So we have d by dx. So we have d of x squared plus y squared in terms of x and the derivative of 2 with respect to x. The second step, we have to use the rules of differentiation. Now, the sum rule is going to give us d of x squared by dx plus d of y squared by dx on the left-hand side. Then differentiating x squared with respect to x gives 2x. Then we have to use the chain rule to differentiate y squared with respect to x. So that'll give us 2y times dy by dx. And then differentiating the constant number 2 with respect to x gives us 0, because differentiating constant is always 0. So that leaves us with 2x plus 2y times 2x plus 2y times dy by dx, and that's equal to 0. Now, after that, the third step. There's essentially only one function that's a product of dy by dx, and that's 2y times dy by dx. So we keep 2y times dy by dx on the left-hand side, and then on the right-hand side, we have minus 2x. Now, actually, for this problem, the fourth step is already complete. The left-hand side is written entirely as a product of dy by dx and another function, which in this case is 2y. So now we have the fifth step. For the fifth step, we have to divide the left-hand side and the right-hand side by 2y. And after canceling out the 2's from the numerator and denominator, we finally obtain dy by dx is equal to minus x by y. Here is another problem. If x squared plus xy plus y squared is equal to 1, then find dy by dx. Don't be intimidated. Use the same techniques. Remember, y is like a function of x. So when you differentiate x times y in your step over here, you need to use the product rule, and that'll give you y plus x times dy by dx after simplifying. Then you can keep working through all the steps to obtain eventually dy by dx is equal to minus 2x minus y, the whole thing by x plus 2y. Explicit and implicit differentiation. Now, what's the relationship between? I want to address a possible misconception some of you may have about explicit differentiation and implicit differentiation. Explicit differentiation and implicit differentiation are two different procedures for obtaining the same result. They are not two different forms of differential calculus where you get two different results and each result applies in different scenarios. No, that is completely incorrect. Regardless of whether you use explicit differentiation or implicit differentiation, you will obtain the same result. Implicit differentiation is simply an alternative to explicit differentiation. Check the problem over here. If x times the square root of y is equal to 1, then we have to find dy by dx. So follow through the steps for both explicit and implicit differentiation. You get the same result. Dy by dx is equal to minus 2y, the whole thing divided by x. Thank you guys. That'll be the end of this video. Make sure you hit the like and subscribe buttons to see my future videos on mathematics. Until then, stay tuned.